Hey everyone, my name is Jonathan Hill, and I'm excited to welcome all of you to today's webinar on what's new in Simcenter 3D and Simcenter Nastran 2019.1. Now I do have a few quick notes before we get started, and we'll give a quick intro to ATA. But before we get that far, everyone has been muted for now, just so we don't have any disruptions or anything in the middle of the presentation. We will open things up for questions at the end of the presentation and demo. And at that time, I'll allow you to unmute yourself, and you can do that with a button in the lower left-hand corner of your screen, I think, at that time. You can also ask questions at any time through the chat, either publicly or privately to me, but we'll probably wait to handle those questions until the very end as well. And then in addition, you'll probably notice that we are recording today's presentation, so we should have that available under the free resources section of our website in the next couple of days. So keep an eye out for that if you would like to rewatch certain parts or share it with colleagues or anything like that. So getting started just with a brief intro to ATA. In addition to our role as a Siemens partner and reseller, ATA is also known for our robust engineering services. And really these two complement each other very well. So when our software customers run into trouble, we're able to provide exemplary support because we have experience overcoming similar problems across a wide range of industries through our services role. So on the services side of things, we offer complete integrated solutions and tend to focus on analysis and test-driven design. So many of the engineers here are working across disciplines to find the optimal solution. And whether that means we're analyzing the next generation planetary rovers or doing ground vibration tests on state-of-the-art aircraft, ATA is proud to help our customers meet their toughest engineering challenges. And then, of course, being experts with Siemens PLM software is one of the ways that we can do that. So speaking of the software, this is a list of the various tools that ATA can assist you with and that we have experience with. So that includes products that we'll be talking about later today, like Simcenter 3D and Simcenter Nastran. But it includes others like CMAP and Start CCM Plus and HEADS and even more. We host a technical support hotline, which is staffed by experienced engineers who are using these products every day. And in addition, we can help with license sales. We offer a variety of classes from introductory topics to more advanced topics. And I would also like to point out that Siemens has recognized ATA as a Smart Expert partner with validated expertise in CMAP and Start CCM Plus. So after the webinar today, I would love to invite you guys to check out our software website. There's a ton on this website. So it has a schedule of upcoming classes and webinars. We have quarterly newsletters that we put out that get put on the site. We also have product information and brochures and links to free trials and things like that. But my favorite part are all of the free resources. So if you come to our site, you can click on this yellow button. That'll take you to our free resources page. And we have a variety of things from white papers and APIs to on-demand webinars and all sorts of really good material that is developed by our own engineers. I'd also like to take this time to say that if you have any topics that you would like to see us put a resource together for in the future, we would love to hear that as well. With that, I think we will go ahead and just jump into the heart of our presentation today, which is what's new in Simcenter 3D and Simcenter Nastran 2019.1. Again, my name is Jonathan Hill. I am an engineer with ATA Engineering in our Northern Virginia office. So it's great to be on the line with all of you guys today. And this is a quick rundown of what I'm going to cover today. So I'll start off just by talking about some new naming conventions and a new release cadence that we expect to see going forward with these products. And then we'll jump first into Simcenter 3D, where we'll talk about user interface updates, pre-processing enhancements on both the geometry and meshing side of things. We'll also discuss post-processing enhancements, some Nastran updates, in particular targeted at solutions 401 and 402. And then we'll cover some additional new Simcenter 3D capabilities before wrapping up with a summary and opening things up for questions. So I think the first thing to kind of get us off on the right path is to ask ourselves, what is Simcenter 3D? And before we even get that far, I think it's helpful to frame it with the context of what is Simcenter, right? So Simcenter is Siemens' portfolio that includes their best-in-class CAE simulation, system simulation, and testing solutions. So this encompasses quite a few individual products like Simcenter 3D and Simcenter Nastran that we'll be talking about today. It also includes others like FEMAP and Star CCM+, in addition to even more like Flow EFD and AimSim and TestLab. And then, of course, all these products can be managed with HEAD's design exploration and analytics tools, and then managed with Teamcenter. So now that we've kind of established that, we can ask, what is Simcenter 3D? So Simcenter 3D is a product inside the Simcenter portfolio, and it's a unified, multidiscipline 3D analysis tool built on the NX platform. And I realize that is a lot to go through too, so we'll kind of unpack that a little bit. Simcenter 3D is multidiscipline. I think we're probably most familiar with it for its structural and dynamics capabilities, but it can do a ton of different things, from additive manufacturing analysis to electromagnetics, thermal and flow problems. You can do acoustics with Simcenter 3D. So it really can target a lot of different analysis requirements. And then in addition to that, it's based on the NX platform. So when I say based on the NX platform, it is available as a standalone application. So you can launch up Simcenter 3D by itself and just go directly into pre-post. But it's also completely integrated with NX. So Simcenter 3D has kind of come out of NX CAE. And so if you launch NX, the CAD tool, and you go to pre-post and start building your finite element model and reviewing results, you're using Simcenter 3D completely embedded in NX. Now, the most recent major release of the software was delivered in January of 2019.1, and there were a few naming updates. So I'd like to kind of go through that as well before we jump specifically into the product. So first, NX 12 has been superseded by NX. So we had NX 10, NX 11, NX 12, and then now just NX. So it's not NX 13, it's not NX 1847. And as you notice, they've dropped the release number. And the motivation for that is that they want to remove focus on the release number as a perceived indication of quality and deployment readiness. So Siemens is trying to drive home the point that every version of NX is good. Whenever a new version comes out, there's not a need, like there might have been in the past, to wait multiple releases in order to make sure that you have a good quality product. And really, I like to think about it the same way that I think about my Microsoft Office package, right? So I'm presenting right now from PowerPoint. I have no idea what version of PowerPoint I'm using, but I trust that Microsoft will kind of deliver timely updates and keep things running smoothly, and won't just crash all of my PowerPoint models. So that's kind of the approach that Siemens is taking with NX. On the other hand, Simcenter 3D 12 has been followed up by Simcenter 3D 2019.1. So we've gone from version 11, version 12 to now 2019.1. And the next major release is expected in June of 2019 and will be Simcenter Nastran, or Simcenter 3D 2019.2. And then finally, we have Simcenter Nastran 2019.1 superseding NX Nastran 12. So we've gone from the 10, 11, 12 to 2019.1 release name, and then we've also gone from NX Nastran to Simcenter Nastran, which makes sense in the context of the Simcenter portfolio. And then similarly, the next major release is expected in June of 2019, and that will be Simcenter Nastran 2019.2. Specifically for NX and Simcenter 3D, there are version numbers, and this will be really important if you call into our hotline with a problem or you're trying to talk to GTAC or anything. These are available at File Help About. And so just for reference, the January 2019 release had a version number of 1847. And then, like I mentioned, these releases have been out since January, so they're available now for you to download at GTAC. You can just follow this link, or you can Google for this link, and then you just need a web key to log in, and you can download the latest versions of software. So in addition to the release in January, that was also the start of continuous release for NX and Simcenter 3D, which is pretty exciting. So the main thing that this means is that instead of a 15-month release cycle where we're waiting a little over a year for new enhancements, now we expect major enhancement releases every 6 months, and these will be accompanied with schema changes. In addition, in between those 6-month major enhancements, we'll see monthly maintenance releases, which you can think of sort of like the maintenance packs they put out right now. Overall, this approach allows both the software and its users to be more responsive to new ideas and trends. So we no longer have to wait a year or two for the latest enhancement to be delivered and then finally integrated into our daily workflows. And really, it demonstrates a commitment from Siemens for each new release to be customer deployment ready. So they're trying to reduce the deployment costs and effort so that it's easier to just stay with the most recent version. Now, one new thing that they've introduced to help that effort out is an optional automatic update. So this is off by default, but when you turn it on, you have two different options. You can have NX notify you if a new version is available, or you can have it notify and download for new versions. Again, it's off by default, and you'll notice up in the top right-hand corner, there's this little circle that has a couple different color options to let you know what the automatic updates is doing. So if you have it off, it'll just be gray. If it's on, it'll be yellow if a new version is ready for installation. It'll be blue while that version is downloading, and then it'll be green if your software is up to date. The other thing I want to point out is that it is possible to have multiple versions of the software installed, just like it has in the past. So if for whatever reason you need to keep a couple different versions on your computer, you absolutely can do that going forward too. Now, jumping into Simcenter 3D and beginning with some updates to the user interface, we'll see that kind of across the board, we have some refreshed icons. And these are intended to provide a clean and modern look. So it's just a little more fresh, in my opinion. Icons are more homogeneous. So for example, all the trimetric icons are now from the same view angle, and some of the colors have been toned down. So it's changes like that. I tend to like it. You can decide for yourself whether you like those changes or not. In addition, visualization preferences are simplified and consolidated. So previously, these options were spread across a couple different dialog boxes, including visualization preferences, visualization performance preferences, and facet setting commands. And now all of those are in the single visualization preferences box. So some preferences have been simplified and restructured for improved usability. One of my favorite things is that on this performance accuracy tab, there's now a little preview window. And so as you drag this edge accuracy and surface accuracy across, you can see what that will do to your model in terms of facet tolerances. There's also an option down here to reset the defaults. You can reset all of the defaults at once, or you can reset just a single tab. And in addition, another new tool that they have that's pretty cool is this large model. So I'll demo some of these when we step into NX in a minute. But the level of detail can reduce detail in a very large model as you zoom out. So for instance, if you have a very large finite element model and you have element borders turned on, sometimes when you zoom out, the element borders kind of take over the screen and everything's black and you can't really see your model anymore. So you can have a setting here that as you zoom out, it can turn off those element borders for you so that it doesn't obstruct the view. And then as you zoom back in, they would come back on. You can also have it reduce the level of detail during dynamic movements. So if you're rotating the model or zooming in or out or something, you can have it hide some of those edges and things like that, just so that the rotation would be a little bit smoother if you're having trouble with that. So those are two pretty cool things. In addition, still talking about UI updates, there is a new predictive UI toolbar. And this predicts the commands that you'll most likely want to use based on what you're doing at the moment. So the toolbar obviously will be different based on each user's use pattern. But just an example of how this would work, if I have a workflow where I commonly create a material, and then I create a property that references that, and then I create a mesh collector, if I go and I create a new material, this toolbar will automatically contain the property and mesh collector commands because the software predicts that those are the next commands that I want to do next. Now in this case, that's not, those buttons are already pretty close, so it would be pretty easy just to do that the traditional way. But if you're normally hunting around through different toolbars and things like this, this is one way to sort of simplify the workflow. And then finally, there are some updates to the part navigator. First, the suppress or unsuppress checkboxes have been replaced with show hide icons. And in my opinion, this is a little more intuitive. So if I wanted to come and hide the datum plane, I could just come and uncheck this show icon and the datum plane would be hidden. That's sort of what I expect. Previously, it was a suppress or unsuppress box that would take the datum plane out of my model, and if the datum plane was used farther down, it would sort of mess things up. So I like this approach, although you can go back to the suppress checkbox if you would like. The other new thing they've done is they've added in a current feature column. And so it's specified by this little icon. So in this case, this datum plane is the current feature. It's like the model has been rolled back to that point. It makes it really easy just to go forward and backward in your model. So with that, I would like to actually just jump over to NX and see how things look a little bit. Again, Simcenter 3D can be launched on its own. In this case, I've gotten the Simcenter 3D directly integrated into NX. And we'll see that some of the colors have changed a little bit and some of the icons and things. I think it's still very similar to what it was before. It didn't really slow me down at all. So hopefully you like those as well. I would like to show off our customer defaults for the model updates. So we have a new software update tab up here. And this is where you can choose if you want your software to notify and download or notify, or if you just want this off. And then up in the right-hand corner, we see the icon showing that my software is currently up to date. So I am on the latest version. In addition, we can take a look at some of those view preferences. So again, these have all been consolidated into this visualization toolbox. I'm actually going to turn on facets here. And we'll see that as I drag this back and forth, it updates in the little preview window. And then when I hit apply, it would update on my model as well. So I think that's pretty cool. We can also come and play with our large model tolerances. Let me set this to custom for a minute. And first I'm going to look at still frames. So I could say maybe at this far out, I want to hide the element edges. So it should start hiding things as I zoom out. There we go. And then as I zoom in, they'll come back. So that could be really useful. Obviously, for a model that's this small, this isn't the coolest trick. But if you had a really big model, you can imagine once you zoom out here, you can't really see anything anyway. In addition, we can set it so that while the frames are moving, it'll start to hide details. And then when I stop moving it, the details will come back. So that's just another way that if your model is dragging a little bit and it's hard to manipulate the model, you can control some of these up here. And also, I'm going to jump down to the part now and look at our part navigator. So like I mentioned, these icons, instead of the show or the suppress or unsuppress checkboxes, now we have these view icons. So I can just click and it'll just show or hide all these different entities. In addition, here's our current feature command. So in this case, I've rolled back to this point in the model. But if I wanted to come back to the most current state, I could do that just with a simple left click in that column. So those are pretty cool. And then finally, this is my predictive UI toolbar. I'm going to come back into, actually, I'm going to jump to modeling. And so maybe a workflow that I have a lot is that I like to make a sketch, and then I like to extrude that sketch, and then I like to put fillets on it, and maybe do some holes or something like that. So if I hit sketch, then you'll see that the toolbar has updated. So now it thinks that I probably want to do extrude next. And then when I do that, it'll update, say, oh, you probably want to do an edge blend. So it's just sort of feeding me these commands and helping me get through. Now maybe it thinks that I might want to create another new sketch, or I might want to extrude something else. So this is, again, can be useful for some very complex workflows, just so you don't have to go hunting all over to find those commands. With that, I'm going to jump back over into PowerPoint. And next up, we'll be talking about some geometry enhancements. So I'd like to start off by talking about some improvements to face from mesh that make it better at handling complex geometry. By complex geometry, this could be geometry from topology optimization or meshes with a lot of curvature, just generally tangent continuous geometry that wraps back on itself. In this case, the UI has been simplified and it generates better faces that conform more closely to the topology of that source mesh. And in addition, they've added a new feature edge control that's pretty cool. So what you can do is you can select an element edge to become polygon edges. We'll take a look at this in NX in just a minute. In addition to using element edges, you can also use beams as feature edges. For imprint, there are two new little cool enhancements for imprint. First, there is a new snap-ins tolerance that you can specify. This helps make sure that you don't have small gaps between your imprinted edge and the boundary of your target face, which otherwise could either lead to stitch failures, or if you have small gaps, then you could have small elements that might have a bad element quality. So snap-ins is a welcome addition. And then in addition to that, we have a new normal to face direction. So previously you could only imprint in a single direction, which was great if that was all you needed. But if you had kind of a curved shape like this and you were trying to imprint a shape or imprint a line onto that curve, it could have been challenging previously. Now you can just do normal to that face. There is a new option to split faces by facet edges. This is another mechanism that's especially helpful for splitting faces with a lot of curvature. Next up, we have datum planes that are now available in the finite element model. This is something that I'm pretty excited about too. So you can either create a new datum plane in the model, or if you have a datum plane in your part or your eye part, you can import that just like you can copy over nodes or points and curves and things like that. Split body has seen some improvements that create all mesh mating conditions as glue coincident. So previously, there was some trouble where sometimes you would use split body and then you would have glue non-coincident, which probably isn't what you would want when you use that tool. So now all mesh mating conditions are glue coincident. And then finally, there is a new edge separation command. This converts a single edge that is shared between two connected sheet faces into two distinct separate edges. So this is useful if you want glue or contact between parts in a 2D model, or just if you want to ensure that separate edges have a compatible mesh with coincident nodes without it being directly connected. So let's go back to NX now and see some of that. I'm going to start off by switching over to the same bracket model, but now a version that only has a mesh on it. So there's no geometry in this sim part. First off, one trick that I like to make the background, it has a gray background. But if we just right click, there's a new background option here where I can just make that white, quick on the fly. But the first thing I want to show off is our face from mesh command. So that's under the polygon geometry tab. And I can select my element faces, and then I can add feature edges. So maybe I like to have my fillets blocked off nicely, so I can just come and select just a single edge, and it'll draw that all the way across, following the most tangent line of element edges that it can find. So I'll say OK, and it created our part. Now I could hide the mesh, and we have our nice geometry in here. And then now I could do pretty much anything I would do with normal geometry, right? So I can come in, if I want to change the number on an edge, maybe I want that to be 6 instead of 3. I can do that. I can update the mesh, see that it makes it a nice smooth curve. I can do things like do a circular imprint on a surface. And then I can also imprint. So here's where we're going to see that we have these two new options. The first is snap-ins. Then I can also do normal to face. So in this case, it would be easy for me to do a vector, but if I had curved surfaces, normal to face would be very useful. So I'll just imprint that right across. And so, yeah, so these are just some of the new options that we have. One other thing we can do is that now that we have this part file in here, we're going to have a new option that lets us convert this body, or convert this to a convergent body. So it's going to ask, and I can select that. It's going to create a new part file now, and it's going to be associative. So we'll see that now I have a part from, this is the same bracket that I had meshed, but I got here directly from the mesh without having a part file or anything first. So that's a pretty cool little trick. I'm going to jump back to my normal part that did have the original geometry attached to it now, because I wanted to show two more things. The first is that I could certainly come up and create my datum plane, but we'll remember that in the part file I had a datum plane, and so I can bring that into the sim very easily. This is the same way that you would specify if you wanted to bring in points or lines, but now there's a new datum plane option here. I'll say OK, and then it'll just bring that in. So that's great. And then the other tool that I wanted to show was edge separation. So this lives on the mesh section of the the toolbar at the top. I can say edge separation. I'll just select an edge. And then now we have actually two separate edges here. So if I set my filter to polygon edge, we'll see that we have an edge now for each of these two faces. And then it's also created coincident nodes, but there are two separate nodes all along this edge now. This does stay together. So if I do any mesh updates, this will stay coincident even though it's two separate edges. So for instance, if I put a mesh control on just one side of this and then I update, both sides will update, even though I only put the edge control on one mesh. So there's some cool stuff going on with that, definitely with the geometry updates. With that, we're going to go back to PowerPoint now and continue on through some of our meshing enhancements. This is going to be the next 2 or 3 slides, but we'll start off talking about surface meshing. And in general, these enhancements improve the overall quality of automatic surface meshes by lowering element quality failures and improving the aesthetic quality of the mesh. So first, the software can automatically identify and preserve special features, including ridge lines, stamped depressions, and fillet chains. So we see that over here. It's going to maintain a fillet change like that. We can see that it has nodes going along a ridge line. It captures our stamped depressions. So that's pretty cool. And in order for it to do this, you need to have both the multi-block decomposition and the CAD curvature abstraction options checked on. In addition, we can get more regular isotropic elements around holes, specifically with the paver method selected, and again, multi-block decomposition checked on. Element size transitions are a little more gradual between different faces for triangular meshes now. We have a few new mesh quality options. So these include aspect ratio, which is the ratio of the shortest to the longest side, as well as minimum or maximum included angles. So now you can specify that directly in the mesh dialog box. And then finally, there's a new option to create a separate mesh for each face. So if we were dealing with the surface over here, I could select 3 different faces in a single mesh, but then create separate meshes for each of those faces. This is useful if you want just a single meshing command to ensure continuity, but then maybe you want different properties, whether that's mesh density or physical properties. Kind of gives you the freedom to do that. Continuing on with some other general meshing improvements, you can now name a mesh while it's created. So when you're in the meshing dialog box, there will actually be a name option at the very top. And this means that you can give your meshes meaningful names. So you can name it after its part or after its material or thickness or something like that. Or for 3D meshes, you can actually have it automatically be named after the polygon body that is meshed. So that's pretty cool. In addition, there are a few very neat new mesh control features. The first I'll point out is when you are doing a number on edge mesh control, there is a new distribute on edges option that will handle connected edges like a single continuous edge. So imagine if you're doing a mapped mesh and on one side of your face, you actually have a few different edges that make up that side. Now you can, instead of having to kind of count and guess about how many elements you need on each little individual edge making up the larger side, you can just select all of those edges, and if they're continuous, it'll take care of distribution between the edges for you. In addition, when we're using the bias on edge mesh control, it now will use the first selected edge as a seed edge to determine the bias direction for other selected edges. So we can see something like this up in the upper right-hand corner. We would select the first edge, and that would set the bias direction, and then every other one, we wouldn't have to worry about it accidentally biasing to the wrong side or anything like that. One other thing that I didn't include here is that when we're using size on face mesh controls, the software will now mesh those faces first, which I think makes sense. But previously, the software would mesh or remesh faces according to the value of their label or ID. So it's not necessarily meshing your size on face first. So this will just help improve the results when we're using that mesh control. Continuing down the slide, next up we have a new remesh command, which is a useful way to quickly modify a mesh for different analysis requirements. So you can see with this picture in the middle, we can either go to a more coarse mesh, or we can go to a more refined mesh. Now, this is intended for remeshing models that don't have associated geometry, but you can use it for associated meshes if you really want to. And a benefit to it is that it doesn't flatten 2D. It doesn't flatten surfaces to a 2D domain. So this means that it could be more efficient and possibly faster than other commands, such as the traditional 2D mesh command. However, it doesn't perform any geometry abstraction, doesn't honor mesh control, and it only works with triangular elements. There is also a new 2D mesh from facets, and this, like the name implies, can be used to generate a mesh directly from facet geometry, which is especially useful for convergent bodies. If we have something maybe from topology optimization like we see over here, this might be too complex to mesh with algorithms that are based on surface flattening without a lot of manual work on the front end. And that's because it doesn't have well-defined face boundaries, it has highly curved surfaces and things like that. So the 2D mesh from facets doesn't flatten the geometry, so it can handle shapes like this very well. And what that means is that if we have a shape like this, we can easily create a 2D mesh on it. And then from there, it's easy to use the 3D TEP-mesh command to generate a solid mesh from that. So this is going to help a lot, especially if we're working with topology optimization or something like that. And then finally, a few versions ago, they introduced a new lattice bodies option in XCAD. And with this latest release of Simcenter 3D, if you have a lattice body from the CAD side of things and you bring that into a finite element model, it will automatically mesh that lattice body with a 1D mesh, which can easily be connected to surrounding solid meshes with the 1D mesh to face command. I have a few other things that I'm going to point out before we hop back to NX now. Starting off with universal connections. Universal connections are valid across multiple solvers and analysis types, and they can be specified on either finite element entities or geometric entities. And the benefit that universal connections provide is they let you avoid manually remeshing these components, which really can save significant time if you need to switch solvers or analysis types or anything like that. So in the lumped analysis, or the lumped mass example that I have here, really all that the user would do is you would specify the location that you want your lumped mass to be at, and you specify, of course, the mass. But then you just say what you want the leg nodes to be. And in this case, it's actually going to create all of these different RB3 elements. So then when you actually realize that universal connection, it will create the CONM2 lumped mass as well as all of these different RB3 elements, and then it'll update as your geometry updates. There are a lot of different universal connection types, so I've sort of shown that drop down here. And in this release, there are a few new ones, specifically crimp, clinch, lumped mass, kinematic joint, and rivet. In addition, this release brings two new commands that can accelerate checks and updates for assembly thems. So first, we have component subassembly label conflicts, which, as it implies, will check for label conflicts in subassemblies or subcomponents and will automatically modify those parts as needed. And in addition, we have a component update pending check, which will check components to see where updates are pending and will automatically update those. Now, both of these commands will work on multi-level assembly thems. So if you have an assembly them that has other assembly thems, these commands can reach all the way down through these different part hierarchies and things. And previously, if we had a large assembly model like this, it could really be a pain to resolve label conflicts and update components following a design change, because you had to go into each of those individual thems and update them. These two tools should really address these problems and make that a lot easier to handle. There is also a new delete unreferenced entities command, which can help clean up a simulation file by letting you identify specific entities that you want to delete if they aren't being used. And then you can choose whether you want to delete them if it's not used by any subcase or just the active subcase. And then you can also have it show you before you actually delete what it's planning to delete. There's also a new element add and remove command. This is targeting solution 401, where there's a new option to define entities that are added or removed at a predefined time or strain. And then we have two updates for bolt preload. you can now create 1D bulk reloads on bar or beam elements. So let's go take a look at just a few of these things back in NX now. Now I had mentioned universal connectors, and I actually have some in this model. So in this case, if we just take a look at one, we'll see what I specified for this. So I specified the target, which for the one side, so it's an RVD2 element and a spring. I created a spring connection, and so basically I just had to say that on one side of the spring, I want a spider to this edge, and then on the other side, I want the node just at the same spot. So I say OK, and then that updates, and I have both my universal connections. There's also the opportunity to specify the coordinate system for the spring, as well as stiffness properties. And then these will update with the model and everything, which is pretty great. In addition, we can take a look at the separate meshes for face. So if I open up this 2D mesh dialog box, I have a new create mesh for each face. When I check that, it'll split all these out to my different faces. Now I only have the one 2D mesh collector, but if I had another mesh collector, I could drag across now to a different type. I could change the properties or whatever I needed to. And I can also go back. So if I didn't really mean to do that, I can just come and uncheck that, and it'll condense them all back down into one. Back in that dialog box, the other thing, up here we have mesh names. So here I could give it a useful name. And if this had been a 3D mesh, I could have it named directly after the polygon geometry. I would like to show off some of the mesh controls first. So I'm actually going to split this edge so that it's two separate edges. I'm just going to split it right in the middle. So now we have, over here, we have two separate edges on the top and then just a single edge on the bottom. I can come into my mesh control, and I can do number on edge. And if I check on this distribute on connected edges, now it's going to have 6 elements across both of these faces, even though this is 2 separate edges. So when I say OK, so this is what it would do previously if that wasn't checked on. But then you can come back and update those mesh controls. Done something here. But we can come back and create new mesh controls now. And then when I update the mesh, now we'll see that on the top, even though each of these mesh controls are for 6 elements, we only have 6 elements across both edges. That's pretty cool. We can also take a look at the biasing options. So now if I go to biasing on edge, and I select a single edge, now this is a seed edge for any other edge. I don't have to worry about what orientation this will go in. They'll always line up. And then we can see, based on this, that it's all going to align the same way. So again, some useful mesh control enhancements. I think we're going to jump back into PowerPoint now, and we'll continue on with our post-processing enhancements. Now, first off, I'll point out that the results tab has been reorganized, and there are some new icons up here. So we'll walk through what some of these icons mean when we get back into NX. In addition, I want to, but before we do that, I want to point out some new capabilities. So we now can measure deformed distances with the simple distance command. That's going to be this button here. And you can choose whether you're measuring deformed or undeformed geometry. You can also position the cutting plane with a reference node. So previously, you just had this little slider to drag it back and forth. But now you can specify a node that you want the plane to snap to. In addition to that, there is some additional customization that's available for the post view header. So it's just more flexible and gives you greater control of automatically generated text as well as custom text. And then there are some new level spacing options. So equally spaced is what we're most familiar with. This will just evenly space the different colors across a specified number of levels. But then we have 2 new ones. So with round off, we specify a minimum number of levels across which the solver, or across which the colors will be scaled. And then for a level increment, we can specify either a maximum number of levels or a range of value per level, and then it'll be used to scale. Continuing on with some other post-processing enhancements, we can now display shell results in projected coordinate systems, which is great. And then in addition to that, we can now display multiple tensor components simultaneously. So this is great, for example, if you want to look at maximum and minimum principal stresses at the same time. In addition to that, Phoebus results can now be displayed as arrows. And so since we can display multiple tensor components simultaneously, that means that if we display our Phoebus results as arrows, we can actually have all three force components displayed at the same time, which is really cool. We'll take a look at that in a minute. In addition, post-processing supports the display of elements that are added or removed. That's what we see in this little animation over here. There's a new option for cached results. So in this case, you can kind of save results to your memory while you have a model open, and this will let you more quickly view the results in post views and switch between different types of results, and really just more efficiently do post-processing operations. Finally, lumped masses are now displayed as contours based on the node that they're on. Previously, the lumped masses would have just been a gray block that would kind of take up your model. So I definitely like that they're now contours instead. So let's hop back over now and take a look at some of these post-processing enhancements. This is just the same model that we've been looking at. I fixed it in the middle, and then I put some bearing loads on the holes up here. Let's just take a look at some of these results. We'll see the parts just getting pulled over to the right now. And I'll start off, I guess, just by looking at some of these new commands up here and some of these new buttons. Some of these are the same, so we still have this dialog box lets you choose if you want a contour plot or mesh-based colors or property or material colors. Edit post view is the traditional command where we can flip between the results, display, deformation, and legend options. And then on legend is where we'll see our different spacing options. So we can have equally spaced, we could have round off, and again, I have some control over the number of levels that it will have, but we'll try to just have nice round numbers here. It's a little hard because the numbers are already so small in this demo. Or level increment, where I can specify a max number of levels or even an increment per level. And then I could do something like that, just to get nice round numbers as we go up. So these are pretty cool changes. We can also go directly to some of the different tabs on the edit post view with these commands. So we can go straight to results or straight to display up here. Now these two commands are going to control whether our cut plane is on or off. And then with this next command, this is going to be our option. So we can still show a preview and then dynamically slide this back and forth. But the new feature with this release is that you can now cut by a specific node. So if I have a solid part that I'm trying to see how far in the stress is reaching or something like that, cutting by a specific node can be very helpful. Kind of continuing across the top, we have some options to show or hide specific entities or to make meshes translucent. And then if I go in, for example, and hide something, I can use the show all button to just turn all the display back on. This is going to let us choose if we want to change between contour, isoline, whatever type of display we want here. This is going to choose between banded and smooth contours. So it's cool to be able to just flip back and forth between those. And then this is a quick toggle between feature edges, all element edges, and things like that. So that's pretty cool. If we're showing something like stress, I'm going to hide our connector elements. This is going to turn averaging on or off. And then we have an option as well to just right on the toolbar without digging down into the post-view settings. If we want top or bottom or top and bottom stresses, maximum. And if we had a composite, there's a button here as well that would let you choose different plies. You can also jump between different deformations with this. And then we have our same query commands that we're used to. We want to come into the model and start querying results. And then here is our measure command. It's now available. And again, we can choose whether or not we want deformed coordinates for this measure command. A couple last things that I want to show here. First, if we want to cache results, you do that by just right-clicking. And then you can specify, maybe I want to cache my displacement results and my stress results. And so now they're sort of saved to memory. So if I had a really big model, this would just help me go through my post-processing operations a little bit faster because it doesn't have to reload them each time. And they will stay in the cache until I either delete them here or until I just completely unload these results. And then the last thing I want to show are our spring forces. So let me turn those back on. This is the view that we're used to if we look at element forces. Not super helpful because it's not related to the direction of the x direction force or anything like that. But what I can do is I can easily just change to arrows. And then I can also edit the display to now display all of our components. And so it will display all 3 arrows on here. There's not much in the y direction, so that's why that arrow is basically not there. But we have our x and our z arrows that are scaled appropriately, and they're the appropriate color. So I think this is going to make reviewing, for instance, spring forces a lot more intuitive and just easier to understand. So I'll hop back over to PowerPoint just to kind of close things out. Thank you for sticking with me so far. Moving on to Nastran enhancements. The enhancements for Nastran this time have focused on solutions 401 and 402. And that starts with the support of restarts for both of these solutions, which is great, as well as the support for user-defined materials. Now, looking more specifically for solution 401, we have a new dynamic transient subcase that allows for the simulation of vibration with nonlinear behavior, whether that's contact or large displacements or plasticity. In addition, there are some contact improvements. So these are aimed at improving convergence. So it includes 2 main things they've added this time. First, we have an adaptive penalty stiffness, which can be automatically adjusted for light or hard contact, as well as for temperature-dependent materials. And then we have some additional options to specify what happens with gaps or penetrations, including a way to adjust penetration within a tolerance, and also being able to specify a delta time to eliminate some initial interference. There's also some element extensions. I'll point out first that we now see support of beam plasticity and creep. Previously, we only had support for linear materials for beams. And then there's the new element add or remove capability that I mentioned, as well as the mid-side nodes are now included in pressure loads and thickness definitions for plane stress elements. And then finally for 401, we can now use 1D elements as bolts, and we can write out intermediate results for preload subcases. So this is some cool stuff that's going on. Moving over to 402, large displacement kinematic effects are supported better with kinematic joints. So this is a universal connection that I was talking about earlier. This makes it easier to model things like hinges or sliders or spherical connections. In addition to that, solution 402 has some new nonlinear gasket and strain rate dependent materials that are supported. And then there's also a new complex modal subcase that captures non-symmetric stiffness from contact. Kind of moving on to wrap up with some highlights of other enhancements in a few other areas. Topology optimization is more robust with this release, with the addition of design objectives and constraints related to critical loads, including buckling, as well as manufacturing constraint improvements that produce better results, or that produce results with better convergence and accuracy. In addition, and this is pretty cool, there's a new additive manufacturing process simulation, which can simulate this powder bed fusion process. So this makes it easier to predict and avoid recoder collisions, distortion, and shrinkage during printing. And then based on that simulation, it can compensate the original geometric model. So this is a really cool new capability that they've added in, and it should really help print a product correctly the first time. which is great. So we don't have to print something and then realize that it shrank or anything like that. There are a few more new capabilities, starting off with the new transmission builder, which can automate the creation and simulation of transmission motion simulation models. Traditionally, this would have been a really tedious and error-prone process, but this tool can reduce that effort significantly, and it allows for extremely fast and accurate gear simulation. One other cool thing about this is that it can actually be combined with Simcenter 3D acoustics for gear line analysis. And then finally on this slide, we have notes that aerostructures, which was introduced with the previous release, adds support for calculating margins of safety on composite structures with this 2019.1 release. And then one-way coupling is now available with STAR CCM Plus and SimCenter 3D, which allows you to turn CFD results from STAR into an equivalent acoustic source for use in Simcenter 3D acoustics. And then finally, for Simcenter 3D flexible pipe, we can study how an electrical wire harness or sub-harness will bend and move within an assembly. Simcenter 3D flexible pipe starts off by importing stocks from NX routing, and it models the interaction between all cables, external taping, contact, and possible section distribution changes, so that we can get a deeper insight into how a wire harness will behave in a moving mechanism. In addition to that, Simcenter 3D Specialist Durability provides the functionality of the well-known LMS Virtual Lab durability solvers. And Simcenter 3D Correlation compares simulation results with physical modal test results captured in test lab, and then it can help correlate the finite element model based on that. It can also help predict where we might want some of our different sensors and things like that. So to kind of summarize everything, first off, just thanks for sticking with me. I know we covered a ton here. Simcenter 3D 2019.1 and the new version of NX began a new continuous release cadence with major enhancements expected every 6 months. On the pre-processing side of things, we see improved robustness in geometry manipulation, surface meshing, and mesh control. On the post-processing side of things, it now allows for measuring deformed distances and gives us greater control over the legend, header, and cutting plane. For solutions 401 and 402, we see added support for restarts in addition to some elements and material extensions. And then there are a variety of new extended capabilities in Simcenter 3D, including additive manufacturing process simulation and the transmission builder. Now, all of this is just sort of the start. And I would invite you to, once we get the slides, you can come and follow this link. And this is going to come up to the Siemens documentation website. So this is available just for anyone to come. They actually have all of their documentation for NX online, as well as Simcenter Nastran and Simcenter 3D. Before this latest release, in addition to tutorials here, they have a What's New section. So you can come here, you can dive into pre-post, and then you can just start going through all of these different options and reading more as much as you're interested. So with that, I would like to open things up for questions. Thank you guys for hanging along for that. I'm going to change it so that you can now unmute yourself if you have any questions, or you can ask questions directly through the chat.